At some point, we need to make sure that you take that test. So when we start talking about testing, you have to go down to the I'll bring you back.
No, Nick. Okay, so you know please stop.
Yeah, so I'm done. All the kids that left on that sheet. I gave 2 days.
They can go see this is one of ours. You can send up 2, and if I'm here, I can help you too.
Perfect.
Awesome, thanks.
Tyler, you won the $20, didn't you? What? You won the $20?
Yeah.
Yeah.
Yeah. Ooh, that's the high school.
Enzo, you're a genius! This girl is a genius.
Oh, man, I'm dropping. I'm dropping.
Abby's so proud. Yeah, I know he is.
I love it. I love it.
The first thing that comes to my mind right now.
All right, so now, Jackie,
What did
sorry.
you get?
What? I haven't taken it this year. The last semester. Last year.
Sorry.
2 years ago.
Hey, what rhyme did it still?
I better get it.
What rhyme did it?
All right. Okay. Now, here's what I want to talk about. Back, let me hand these out so we can discuss it. Now, Jackie, your scores won't be entered. Sorry, you turned it in a little late, but we'll adjust to what you're doing for this. All right.
Oh, is this the thing we did after the test?
Yeah, because I know some people are like, when can I see that? And we will talk about your test today, but after, because I need to send it for Monica. All right, because you guys were, I had a lot of questions like, hey, what's that problem-based instructional task? You know, what was that worksheet we did Friday? So that's what I want to discuss today. All right. I want to discuss what that thing was. So let me hand these up. Okay. Darcy? Okay, Jonah, here you go. Yeah, I'm going to want these back. I want these back. Okay. See, answer's going back. Fine. Burke. Burke's gone back. M, here you go. Sorry. Taylor. Jack. Nick. That's funny. That gives me a little less. Honor.
Oh, I missed these two.
Wait, are these actually in the grade book? Thank God. I didn't know this.
Okay, Jackie, here you go. Sorry, I didn't get your first. Alright, so this is yours. Alright.
Oh, I did 8 right.
Alright.
Oh, yeah.
So now. Oh, and Amy's. Alright, hey, let's talk about these right now. Okay. So now some of you are asking what that was. Why do we have to do it? Now, it was based on Algebra 1. Okay? Would you like one? Okay. So because a lot of you are asking what this is for. This is a little project that me and Ms. Stephens were working on. Okay? So I want to go through the answers. That's what. I want to make sure that you can see, like, why did I get it wrong? Why was it? What was the answer? Now, let's talk about it here first. Okay? Okay, so this is your problem. This is that graph you guys had to look at. I think some people misinterpreted the graph. They didn't see which ones were supposed to be connected. This is the women, and then the men are right. Okay? And then there's a series of questions about it, like use the following graph to answer the questions below, and then there's, and have that big story like beyond popular belief, blah, 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 blah. Some people need sleep. Okay? All right, so that was kind of the setup to it, right? It was based on a real life type of problem, a study that was taking place. Okay, so here's the type of things. The first thing I want to talk about is the scores. Some of you were asking about your scores. Obviously, you're looking at them right now. So, this was the distribution of scores. Okay, it's right here. So you can kind of see, this is in no particular order. I didn't want to put it in like alphabetical. I didn't want to put it like least to greatest because then just like a curve. So I just kind of put it, however you turned it in, that's how I entered it in the grid. Okay, and they're not in the grid book, okay? Because this didn't go against scores. It was just a little project. So there, you can kind of see where you fall at the scores. So this is the total points. This is the questions, or how many kids were in the actual room, that type of thing. So you can kind of see. Now, here's the problem. What's the problem with the score? Yeah, no one got a 20. No one, in fact, got above a 16. Okay, so that's one red flag right there. No one got hurt. Next, talking about why did we do this? Okay? I want to see, out of your class, how many could actually handle this worksheet. What I mean by this, proficient at doing this, almost proficient, and then failing. Okay? So, this is the total number of kids that took it, 16 so far. Okay, here's your proficiency. Here's the people that were almost, and here's the people that are not proficient. So you can kind of see kind of the, so if I put these in order, it basically looks like that. All right, so you can get a feel for that. Now, the average of this room alone, this room's average was a 12.5 out of 20. So, okay, that's just above failing. Just to give you an idea.
We didn't fail.
You didn't fail. You were, well, some people did, but the average was just above failing. Here's the problem. Okay, so there's the average line, by the way. The average is pulled up by these outliers. Okay, it would have been lower if all these people didn't score like 16. Okay, so now, here's the problem. I did lie. I lied to you a little bit. This was actually meant for you guys. This is Algebra 1 material. So, this is something we need to get better at. It's been, what, 3 years since you've seen Algebra 1. You're seeing your level right now. We need to get better at this. This is something you need to be able to do. Interpreting graphs, graphing linear equations, coming up with best fit lines. Those are things you should be able to do from Algebra 1 that you obviously have not retained knowledge of, right? So, now let's go through the answers so you can kind of see what I was looking for now. I gave a little leeway. There was a little buffer zone. You didn't have to be perfect. So some of the answers I'm going to talk about today may not look exactly like yours, but you may have got some points for it. All right, so let's go through the questions here, right? So, first question was, at which age, to the nearest year, do women have the least number of awakenings during the night? So, it was in this range. So, women are in purple here. The least number is right here. I would say like 8 or 9. That's the year. This is the ages. Going this way. So, about 8 or 9, they had the least number. Now, what was that number?
Oh,
Yeah. Yeah, the least number of wakings was 1. How do you know that? Duh. Right next to you. Okay, there was 1. I had some people putting halves. I think you're looking at the wrong graph. So, okay, so that was all you have to do. That is data interpretation from a graph. That's something you should be able to do, especially match testing, ITBS testing. They test you on that. They have you look at graphs, tell me data from it. Okay, now, same question, but now for men. Okay, so it was the exact same question, but for men. So, what was the greatest number of awakenings that night? What was the greatest number? Did I skip this question? This means your average wakings.
Number 3 is 2 questions in 1.
Oh, that's why. All right, so yeah. All right, so men have the greatest number of awakenings. Right there. Okay, so that's about the greatest. So that would be roughly 65-ish. So like right in the middle. If you draw these lines straight up, it falls almost in the middle. So I would take it somewhere around 65. And then the second question was, it was a two-parter. What was the average number? So what was that number roughly? 8 roughly. I had some people put 7.7. Close. In that range. I had some person put 4. Not 4. Okay. All right. Now let's go to the second parts here. Estimate to the nearest 10 the difference between the average number of 25-year-olds. So 25-year-olds are right in this range. So we just kind of round to the nearest 10th if you can. So 25-year-olds women had about what? 1.5. Okay, men had 3.25 maybe. And then what you do is you find the buffer where you subtract things from each other. And that number is roughly like 1.5 maybe. Because if you're subtracting decimals, you line up decimal points and you subtract straight down. Right? So 5, borrow, it's 7, you subtract with 1. So 1.75 to 2-ish, somewhere in that range. Maybe you're just 2. I had some people putting like 4 or 5. That's more than both of them combined. So that doesn't make sense. So that was testing whether you could just add or subtract decimals. Okay, then, second question. Estimate to the nearest tenth the difference in awakenings for 18-year-olds. So 18-year-olds, I would say that's like in this range. Let's say that's in that range. That's the 18-year-olds. This is 15 maybe. These are 15, so I would say it's probably these two numbers right here. There's your 18-year-olds. So that's the number roughly the number 2, and this is roughly the number 3. So the difference between them is 1. That's what I would say. That's the difference between 18-year-olds. Okay, even if you pick the other numbers, we're still about 1. I had some people tell me 2.7. 2.7? Is that possible? Are you finding the midpoint, or are you finding the difference? All right, now, use the following questions. Graph the best fit line for men. This is one that I just got a lot of people to go, what's a best fit line? Something from algebra. Okay, a best fit line for men is a line, so if you draw an imaginary line that would pass through the middle of your data. What most people try to do is they try to hit as many dots as they can when they do a best fit line. I just go like right down the middle of your data. So this to me looks like a best fit line. So it's the best fit for what, how does the data look like it's traveling? That's like the best way I can explain it. Does the data look like it's going up? Does it look like it's going down? Boom. That's what it looks like it's doing to me. Does that make sense? Do you agree that it's going up to the right? Yeah. So that's my best fit line. And then all I do is the second question, so I drew it. You have to draw it, graph it. Some people like drawing their own mock versions of it. Just go to the front page so I can get the ruler. So draw the best fit line for men. And then you had to come up with the linear equation for it. Well, how do you write the linear equation? What's a linear equation written as? Anyone remember the different forms of linear equations? Yeah. All right. Slope-intercept form. That's one. So if you don't remember slope-intercept form, that's y equals mx plus b. That's one way you could write the linear equation. You can do it in point-slope form, which is the preferred method. Yeah. Point slope is y minus y1 m x minus x1 and or standard form. Now there is a general form, but we'll get to that one later. But standard form is some number x plus some number y equals c. That type of thing. The one I prefer is this one. You don't have to do any actual work. The only thing you really will have to do is plug in slope. That's all you're going to really have to do, and then you just plug in the coordinate. This y and the first x are not actually numbers, they're just variables. These are the actual coordinates. So the first thing we need to do is we need to find slope. Slope is the difference in y's over the difference in x's. So if I just pick a couple of these coordinates, I'm going to pick this one right here and this one right here. And that's for the men. And I'm just picking coordinates where the graph actually hits. So this spot here is 70, 7. 70, 7. This spot here is 10, 1. That's the coordinate that I picked right here for the men. For where my best fit line goes. And then I subtract them. So the y numbers are the 7 and 1. If I subtract, I get 6. And then subtract the y numbers, I get 70 minus 10, which is 60. And I can simplify this to be 1/10. So there's your slope. And now all I have to do is pick a coordinate. What's one of the coordinates I used? 77 or the 10, 1? Which one do you want to use? 10, 1. So x is a 10, y is a 1. There's your equation. That's the equation. Now what that's useful for is that if you need to go, like, look at the last question. What was the last question? Like, how many times does somebody wake up if they're 100? You can plug in 100 here. Plug it into the x's. plug in 100 here, I can literally tell you what the answer for y is going to be. Because it'll give you answers out. That's what linear equations do. They can help you project what's going to happen later. That's what we use the best fit line for. Now, you can do that for the second one. You can do that for the women as well, because that was the next one. Okay, for women, same thing, come with the best fit line for women. Well, women start here, and they're going kind of up, and if I go through the middle of the data, looks like women are roughly about right here. If I go a little bit lower, there's the women. Maybe if I tilt it a little bit lower, because I want to try to get through more of the data. That one's kind of an outlier, I think. But looks like it's kind of more tapered, so I would pick maybe 1, 10 again, and maybe 60, 5, maybe. Little dots where I'm kind of roughly hitting with my graph. And then you can kind of guesstimate and do the same work over there. So you can get that same work that I did for point slope form, but you can do it for the women. So so this is 60, 5. This is 10, 1. And we can come with the equation for women. That's that second question with the linear equation for it. So 6 minus 1, or sorry, 5 minus 1 is 4. 60 minus 10 is 50. So that's your slope. X minus, I'll just use the first x coordinate. And that turns out to be what, 2/25? 2/25. And now we can go on, because now I have the equation for men, which is over there, which I circled, and I have the equation for women. And now what we can do is we can go into that last question that says, hey, what will happen at age 100? Make an educated guess, so I changed it to for a man at age 100, because it said for a person, right? So it's one or the other. So if you had to have at least 2. I mean, some of you just kind of guesstimated, maybe 6 or 7. Some people said, maybe 10. You know, it was an educated guess, right? Because that's all I said, an educated guess. Well, you wouldn't need to make the guess if you had the formulas. So it's going to get it. You can use the equation to actually help figure out, because it's doing a projection. If I want to do it for women, I just plug 100 in here, age 100, minus 10. You can times 2 over 25, and it'll give me kind of a rough number what's going to happen. Okay, if I keep following, where is it roughly going to be? I would say maybe up here somewhere. You can plug that number in. 100 minus 10 is 90, take 90 times 2/25, and then add the 1 across, and you get your answer for y, and that's the main way to use y. My goal in this chapter is obviously you're seeing right here. The goal in this chapter is to try to get better at this stuff. Can you do the simple linear equations? Now, granted, it doesn't go in the grade book because it was just kind of I want to see how well you do. I want to get some data behind it. How well do you know your algebra 1? Well, not very well. So we got to practice that. Okay, does that make sense? I want to put some real numbers so you can kind of see what we need to figure out. Okay, question?
So from the best fit line,
Yeah.
did you add all of the numbers up, like for each 10, 20 through 80, and then divide by how many there are and get an average?
That would be kind of like a z-score in like statistics, right? You find the average and you kind of go through the middle. Yeah, that's kind of what you're doing, right? You're trying to find the average. The problem is if you add these numbers up and you divide, you get the middle of them, right? You get the middle of them. Well, the best fit line is literally doing the middle of x and y, going all the way up. That's what you're doing. So you'd have to find like the average here, the average here, the average here, average here, average here, average here, and then draw a line that connects all of them. That's kind of like the best fit line. Most math textbooks just refer to as the best fit line is just eyeball it. Where's the direction of the data traveling? So is it going up to the right? Is it going down to the right? Is it just leveled off? Did it curve? That type of thing. And we try to fit a line that goes to it. Does that help you out? So it doesn't have to be like super specific. Like what I did is I just put a ruler for everything, kind of rough line. Just trending your data with common sense. questions, comments, concerns? Stefan, you got anything to add? Okay. All right. I thought this was kind of fun. I want to see how you do, because it was like I gave you no instructions. I want to see if and a lot of you are just you did pretty well. You did a lot better than some of the other classes did. So. I could show you their averages, but I don't want to. So. All right. But I'm going to take a look back. I'm going to send you to the.
What do you get?
I'm going to send you to the statistics room, yeah?
I was squaring.
Average.
Okay, I won't be here tomorrow, but maybe I can come as a longer, so she'll be ready for it. Just make sure I get my practice test.
Yep.
Okay, thank you, sir. I'll send somebody to come get you once we get done. We only have about 10 minutes, so I don't know if we'll get done with the review here. So. Alright. Okay, now test time. Let's take a look at these scores. Okay, and again, I want these back in not just keep these.
What happened was he started off his young tight end career making an incredible catch for one of our best defensive players.
The jamboree. Made a bad impression, jamboree. Yeah.
What?
Alright, everyone got a test in front of them? Alright. Okay, alright. Let's take a look at the test itself and see how well you did.
This is a perfect ball.
Wait, I would
like my
life savings on Colton.
It's the best ball. All I had to do is
All I had to do is go like this.
It was right. But still.
I was like, hold on, I think you could do it that way.
How you spike that?
He shut up.
That's what I would have done. I did better than I thought I did. I would have went over to Sherwood. Yeah, probably not going to bring it down that much. I don't see why.
Alright, here we go.
I didn't want to see if I failed.
Okay, so is that a 47? Remember, you have a week from today if you wish to retake it. But again, it'll be the same format. It'll just have a different problem statement. So you have to show me without a doubt you know how to do these. Okay, so if you choose to retake it, now don't email me, don't talk to me. Just show up in the morning. We'll go through paperwork, and then you can retake it at a later time. But it's got to be a week from today. That's your last kind of warning for that. Okay, when you factor this, it's a trinomial. This symbol means it has to automatically go plus minus. Then you're breaking up the 2x squared and the 3, and that combines to make the 5 in the middle. And it does matter where you put them. And you can actually see I was kind of working it out and I can erase some stuff. Because I need to make sure that the 5 in the middle is positive, and that's the hardest part about it. So 1x and a 2x, so when you multiply that, it makes 2x squared. 1x times the negative 1x is negative, is a negative 1x. Then you multiply the 3 and the 2 in the middle, that makes 6x, and then when you combine those, those make 5, and then the 3 times negative 1 is make 3 in fact. So it did matter. You had to put the 1s so that they're opposites, and then the 2 and 3 in the middle, or vice versa, or block. But these are the two parentheses I was actually looking at. And that's the symbols are important. Okay? All right. Let's see. All right. Number 2. It was a different squares plus minus. You break up the 64x squared and 8x and 8x, break up the 81 to 99. That's pretty straightforward. I had somebody give me the wrong thing. They put plus minus can do difference of squares. It's got to be opposite. Number 3 is the cube rule. This is one that went kind of awry. For cube rule, you take the cube root, you take the cube root, right? So x and a 4. Then once you have this, this is how you make the rest of the parentheses. So the next symbol will be the opposite, and then there's always a plus in the back. It was so same, opposite, always positive. Then how you make this item? It's this item squared. The middle is these two multiplied together, ignoring the symbol. And then the back item is this thing squared. That's how it works. That's how you do differences. Or let's say you do a cube rule or factor. 4, grouping methods. The first thing you do is pull out x squared here, so it's x plus 6. Pull out a -2 from this, so that would be an x plus 6 if I pull out a -2. Then you notice that the x plus 6's, so if I take the x plus 6's to the back, these two things are left. Some people forgot the square, so you lose points. Number 5. First thing you should realize, they had something in common, so I pulled that out. I pulled out the 3y squared. So I pull out 3y squared, this is a 16y squared, and that's a 1. That's a difference of squares, so it's 4y, 1, plus minus. That's the thing. You had to keep going. Some people didn't go for it. Okay, let's go to the second page. All right. For number 6, first thing, you had to pull out a 4, thinking this. On the bottom, it's a difference, it's a trinomial, so it's minus minus, x, 2, 2. That's how you make the 4 in the middle. These cancel out, and that's your final answer. But you also have to tell me the exceptions. The exceptions on the bottom was just the 2. You can't plug a 2 in the bottom because it would make 0 for the denominator. That was a big thing. Some people were like going through these problems and they forgot to tell me what the exceptions were. You have to keep going. Okay, number 7. You have to factor all that stuff apart before you get to, before you try to simplify it. So factoring this, I pull out the x. So that's x squared minus 25, and then that was a difference of squares. So you can see it here. The bottom, you can't do anything with that. This, I pulled out a 2, and then it turned out to be a difference of squares. And then the bottom, it's a trinomial rule, minus minus 5 and 1. Up here, this switched, so I pull up a 7, as you can see over there, and then the bottom I pull out an x. And then, as I was going to multiply across, because again, why flip this? It was division, so you have to do the reciprocal, right? Now I can cross things out diagonally. So like I did the x minus 5s, I did the x minus 1s, I did the x plus 5s, I did the x's diagonally. And then the 2 here, and then the 4 simplified. That went away, this made a 2 down here. And when you go straight across, you have to write down what's left. What's left on the bottom is the 2 and the x squared. What's left on the top was basically this x plus 1, and the 7. And you can see what I have there. And then the exceptions, anything that would make the bottom 0. 0 for sure, 5 and 1, here and here, -5, and then also what was originally there, which was a -1. A lot of people didn't realize you had to go through the original problem as well, like you can't plug a -1 in here as well. Some people forgot that. Okay, number 8. Same idea. You had to factor this bottom part as x plus 5, x minus 4, and that would become the denominator. So in this middle term, I had to put an x plus 5 on it. You can see it there. I had to put an x minus 4 on this. Over there. And notice how I wrote it, because I'm not distributing 3 yet to the x plus 5 that I put on this, or the x minus 4, because I need to make sure the symbols are in front of it, the minus signs and the plus signs. Then I distribute that next, which would make 3x, 15, -5x squared, and positive 20x. And then I can combine terms, and you can kind of see what I got down to. And by the way, I've done this problem like 3 times before, so I'm working on it really fast. This does not factor apart. And so the only exceptions were the -5 and the positive 4. Okay, 9. 9 was the easiest problem. All you have to do is multiply everything by x's. Get rid of the complex fraction here. If I multiply this by x, it's just 1. Multiply this by x, it's an 8x. Multiply this by an x, it's 4x. Multiply this by x, it's a -1. You cannot go further. Do not divide these by 4s. Because if you're dividing those by 4s, you have to divide those by 4s. And you just made a complex fraction again. So you can't just divide them out, you can't just cross things out. As somebody told me, it was 2, not 2. You can't cancel x's or the -1s. I mean, this is it. Your exceptions to this is what would make the bottom 0, which is if I set this equal to 0, it would be a positive 1/4. Or on the original problem, 0. You can't put 0 in the original x's. On the original problem, some people forgot that. Okay, 10. I completed the square here. Yeah, I completed a square on this problem. I didn't do any of the rules. I know some people did like quadratic equations, which is fine. You move the 11 across first. Take half the middle squared, and you have to add it to both sides. This is where somebody went wrong. You forgot to add the 9 to both sides when you complete the square. So then that makes 20. Now I can factor this apart to be x minus 3, which is x minus 3 squared, and then you can get rid of the 2, which you can see I took the power of 2 over to the other side, and did the square root of 20, which I showed you over there, and then I bring the 3 across. So it was that was the steps. For those are the two answers. 11. I multiplied everything by 30. So if I multiply this by 30, the 30 and the 5 simplify to be 6. 6 times 3x is this. Multiply this by 30. The 30 and 2 will simplify to be 15. I take 15 times the top, which notice I didn't distribute it yet. Over here, if I multiply by 30, the 30 and 3 will cancel to 10, and I take 10 times the top. And I distribute the work, and then I solve for x, and x turned out to be a 25/7. That's just how it works. Some people did not. Some people got to this, and then, oh my God, you couldn't solve it from there. Makes me worried. Makes me nervous. All right. 12. You cannot just square both sides first. What was the rule for when you do square roots? You have to get this by itself. So I moved it over here, and I moved the 1 across. So it looks like this. That way, the square root is positive. That's what I wanted to make sure. It wasn't a big deal, but I just made sure it was positive. Then you can square both sides. So if I square this side, the square root symbol goes away. If I square this side, you have a binomial. You have to FOIL it. Then if I move this stuff over, it is actually factorable. So it is actually factorable. And it breaks out, and your answers are 5 and -2. And some people are like throwing out numbers like, oh, you can't use -2, and you can't use other things. You can use them both. They're not going to cause any problems in the original problem if I plug them in. Because if I plug in a -2 here, it's still going to be a positive number here. Some people are overthinking that. Okay, there you go. Any questions on this? Okay. Again, you have a week from today if you wish to retake, but again, it will be a different test. They'll have different numbers. But if you want to, just come in the morning or after school. You don't need to email me or anything. I'll just expect it. Now, note, I will not be here tomorrow. Okay, I'm gone tomorrow. I'm at the AEA office with the math department all day. So you'll have a sub here tomorrow. It'll be pretty straightforward. It'll be notes on linear equations. That's pretty much about it. Okay, makes sense. I think Miss Stephens, you'll be in the room as well, so she'll be able to help if the sub is lost. She can take over the sub. Okay, so it's pretty straightforward. We'll intro chapter 1.1. Just to warn you, chapter 1 goes really fast because it's just algebra 1 stuff. You saw me do it today. Okay? So it's basically like every day is a new section. Except for the days we do. Does that make sense? So it goes pretty quick. It's not. We don't take as